Hello, everyone. Good afternoon. Welcome back to the training. Let me know if you can hear me clearly and you can see my screen. All right. So in the previous session, we spoke about IPv6 addresses and we tried understanding how the IPv6 looks like, what are the different rules which can be used for shortening down the IPv6 address. Then we also spoke about how the hexadecimal characters starting from 0 to 9 and then A to F can be translated into the binaries. Today we are going to take the discussion ahead where we will speak about the different types of IPv6 addresses and we'll also try a quick lab for understanding how IPv6 configuration works and how the routers can be enabled for managing the IPv6 configurations. So I hope you all are excited for this particular session. Later in the session, we are going to speak about automation as well, and would be looking at a quick uh, example of a script that I'll try to explain to you all how a script can be used for implementing certain tasks on network devices. So let's get started. Let's begin this session. I'm hoping my screen is visible, and we are going to talk about first IPv6 address types. Just a second, guys. All right, sorry for the delay. So we are going to talk about now IPv6 address types, and we will understand what are the different types of IPv6 addresses. When we speak about IPv6 address types, there are three types of IPv6 addresses. One is your unicast address, which is used for one-to-one communication, as we have discussed earlier also. Second is your multicast address type, which is used for one-to-many communication, where we address a particular group. And third is anycast, which is a new type of address, which we find only in IPv6, which is one to nearest. So we have learned earlier what is unicast, what is multicast, but we need to know what is this anycast. Anycast address can be assigned to multiple devices in different locations. And the device which would be nearest to me, I'll reach out to it in order to fulfill my requirements. For example, if there is a PC and then there is a server, I make a direct communication with this PC. So that's a unicast communication, right? Then there is a PC, there are multiple servers, and I speak only to certain servers. Let's say just with the first server and the second server. So that type of communication is multicast. Now, what happens with the anycast? Same IP is assigned to multiple servers. Let's say to the first one, then to the second one, then to the third one. So in case when I want, let's say some services or some data from one of these available servers, what I can do is I can reach out to the nearest one. This is the nearest one, so I'll reach out to this one, and that would be my anycast communication. So in a situation where multiple devices can help me with that particular data or information, I can use anycast communication by applying same IP on all the given servers. Make sense? Are we all clear? What is this anycast communication type? Yes, perfect. So now it's time to understand what are the different ranges which we use for these different IPv6 types. First of all, we'll talk about unicast. Under the unicast address types, there are two types of IPs. First is global unicast address, which is much like the public IP, which we use in IP version 4. So just like there is public IP addresses for reaching out devices on internet, here in IPv6, we call such addresses as global unicast addresses. These addresses start from a given range, which is 2000. In an IPv6 address, how many bits are there in total? Let me know in the chat. 128, right? So the series starting from 2000 with the first three bits being reserved is what we use for global unicast IP addresses. So the first three bits will remain reserved as the network part, and the remaining can be used as the available address space for the public IP addresses. Second type is link local address. Link local address is something which is automatically generated for the communication which is local to the link. So just like we use MAC address for checking the hour, I mean, for basically exchanging data on layer 2, and we use the protocol R for checking the MAC address of the devices. Similarly, there are certain protocols and certain services which work locally on the link between my devices over IPv6. So for all that local communication, which will happen just between the two devices which are connected on the same link, we use link local address. And these link local address start from FE80 double colon, and 10 bits are reserved. So the first 10 bits will remain like this only, and the others can be modified and changed. Then we get multicast addresses. Now, if you can recall, EIGRP uses a certain multicast IP, which is for exchanging updates. Similarly, RIP also uses a certain multicast IP. OSPF uses a multicast IP, and all of these multicast IPs are reserved already for this type of communication only. Correct? So here also in IPv6 also, we have some multicast IP addresses which are used for certain types of communication. The very first one in that is FF02 double colon 1. Now you see there is no broadcast communication here. So in IPv6, the multicast IP FF02 double colon 1 itself is used for broadcasting something, as it will send the data to all the devices which are there. Clear? So it does the broadcast through the multicast communication only. Then the second IP is FF02 double colon 2. This is used for sending data to all routers on the segment. Third is FF02 double colon 5. This is used for sharing data with OSPF routers, just like 224.0.0.5 was used. Then FF02 double colon 6 is used for OSPF DR, designated router. FF02 double colon 9 is used by RIP, and FF02 double colon A, which represents 10, is used by EIGRP. So these are some famous or most of the times used multicast IP addresses, which are specified for the following type of communication. Clear, guys? Finally, there is Anycast, which I have already explained you. Anycast address type is used for making something communicate with multiple devices. So when I have, let's say, multiple devices configured with the same IP address, that would be a Anycast communication. So if my PC is connected to 3 servers, and when I make communication to the nearest one, that's my Anycast communication. So any IP can be assigned here on these servers, and that same IP should be assigned on the other ones also. Clear? This is how the 3 types of addresses are used in IPv6. Now what we are going to try is we'll try a lab of IPv6 static routing, where we will use certain networks. So I'll take router number 1. I'll connect it to a LAN network. I'll connect it to router 2, again with a LAN network. Here on the left side, I'll use the subnet 2001 double colon, 2001 1 double colon /64. So /64 means half of my address I am reserving as the network part. And the remaining 64 bits are used for assigning IP addresses. Between the routers, I will use the subnet 2001 colon 2 double colon /64. On the right side, I'll use 2001 colon 3 double colon /64. This is going to be my lab. On this lab, I'll use static routing to make my first segment communicate to the other segment. If there is any queries or doubts, you can let me know. Otherwise, we'll move on to the lab part. Link local is a part of unicast address type, as I have explained here, Michael. Same IP can cause duplication. How can we assign same IP to different devices? In the anycast type of communication, there are multiple members which participate in the same group. So that's not going to create any problem of anycast communication. If you are accessing some resource or services from a server, and there are multiple servers that can fulfill that requirement or request, you can put IPs which are same on these devices, and this is going to be helpful for you to make the one to nearest communication. These are some special type of, we can say, IPv6 addresses that allows you to make one to nearest communication. Yes, Nicholas, FF02 double colon 1 will send data to everyone. So it's a kind of, we can say, the broadcast IP. It's going to put it to all the device. The address you have given, I think, have 6 groups of zeros. Exactly, that's correct. No, it's always going to be double colon only. Even if there are 6 groups or 7 groups, whatever number of groups, the representation will be just with double colon, not with triple colon. Here, Sham. Laid back, there are no classes here in IPv6. The address spaces are divided, like I mentioned. The unicast addresses will always start from 2000 series. So that's how these are divided. Multicast addresses will always begin from FF02, as you can see. And yeah, so these are divided like this. The address space is divided completely between these three types of addresses. There are no classes like we had in IPv4. Definitely, it's a little tricky because I mean, it's not complicated, but it's something different. So for the first time when you read it and understand it, uh, it might sound a little complicated. There you go. Syed has mentioned the expanded form. Can we have a global and link local in the same interface? Yes, Nicholas. When you put a global unicast IP, a link local is automatically generated. Sure. What do you want me to repeat laid back? Let me know. I'll give you the idea of that with the practical part. As of now, just understand that all of our unicast addresses will begin something like this. No, Sayed, we are not going to represent in IPv4 form. So here the things are different. /64 is written as /64 only. We don't mention 255, 255, 255. We configure it with a slash value itself. So no need to translate it. What is the range for Anycast? In IPv6, Anycast doesn't have a dedicated range. The multicast IPs which we use, we can use them for making Anycast communication by setting them in the same group. So if they participate in the same group, there are multiple devices. So automatically the nearest one will be reached out. That's how Anycast communication works. /10 means the first 10 bits are reserved. Yes, these are the predefined reserved IPv6 addresses for multicast communication. And if you can see the pattern, it's same like IPv4 multicast addresses. Like in IPv4, it is 224.0.0.5 for OSPF routers, right? Here it is FF02:5. Similarly, in IPv4, 224.0.0.6 is used for DR. So here it is FF02:6. And then EIGRP, RIP, all these have the same one, right? So I don't think so. It should be hard for you guys to memorizing this part. All right, so it's time to have a quick look on configurations. We'll try creating a lab looking like this with the same mentioned networks. And there we'll get a better clarity on how IPv6 addresses are configured and how the link local addresses are generated. So I'm sharing my packet tracer window. Okay, my packet tracer window must be visible now. So here we will create the same topology that we looked at in the notepad. I'll take two routers. One will be present here, one here, two switches, one here, and then some end devices on the left side, some end devices on the right side. I'll connect the cable now simply like this. Like we decided, the network on the left side is going to be 2001:1:/64. Between the routers, it will be 2001 colon 2 double colon slash 64. And here it's going to be 2001 colon 3 double colon slash 64. So I'll get started from my first router. I'll go to the CLI, say no to the question, enable configure terminal, host name R1. Once we are on R1, we'll go to the interface FA00 and we will apply IP address on it. What is the command to apply IP address when we use IP version 4? IP space address, correct? Now we want to apply IP version 6 address. So I'll say IPv6 address 2001 colon 1 double colon 1 slash 64. So from the network, I'm using the first IP on my FA00. Then I'll say no shutdown, exit. Similarly, I will apply IP on interface FA01, FA0/1, IPv6 address 2001 colon 2 double colon 1 slash 64. No shut, exit. Let's go to router 2, CLI. I'll say no to the question. Enable config T, host name R2, interface FA00, IPv6 address 2001 colon 2 double colon 2 slash 64. No shut, exit. Then interface FA0/1, IPv6 address 2001 colon 3 double colon 1 slash 64. No shutdown, exit. Is that clear to everyone? How we are applying the IPv6 addresses? DHCP is not something we are looking at here in CCNA. So that's a different topic to be addressed with IP version 6. We'll not be using that right now. I'll put static IP on my end devices. So I'll go to my PC, desktop IP. In IP version 6, I'll put the IP here 2001 colon 1 double colon 2 slash 64. And my gateway, see, this is the link local address. It automatically gets generated, right? We don't have to enter anything here. And my gateway will be 2001 colon 1 double colon 1. That's how the IP is configured for a PC. Clear, guys? Now I'll go to my next PC, PC1, desktop IP 2001 colon 1 double colon 3 slash 64 with a gateway of 2001 colon 1 double colon 1. Similarly, on my PC2 also, I'll go to desktop IP 2001:3 :2/64 with a gateway of 2001:2:1. Sorry, 2001:3:1. PC3 desktop IP 2001:3:3/64 2001:3:1. Is that clear to everyone how we have assigned IPv6 on these four end devices? We have given the IP as .2.3 with a gateway of :1, and similarly 3:2 3:3 with a gateway of 3:1. Perfect. Now we are going to add static routes. Now to enable IPv6 routing, first of all, there is a command that we need to put, which is IPv6 unicast routing. This command enables the router's ability to work with IP version 6 addresses. So we will need this command on both the sides, IPv6 unicast routing. This enables routing for IP version 6. Now we will add static routes. On my router 0, I need to put a route for 2001:3, right? On my router 2, I need to put my route for 2001:1. So let's do that. I'll go to my router. I'll say IPv6 route 2001:3:/64. What will be the next hop? Can I say IP of FA00? So I'll enter the IP of FA00, which is 2001:2:2. Simple, right? Similarly, I will go to my router 2. I will say IPv6 route 2001:1:/64 with a gateway of 2001:2:1. And that's all what we have to do. Now, after this, I can go to my PC and I can check my reachability to the other network by pinging 3:2. As you can see, I am getting replies back from 3:2 that confirms a reachability between my PC0 and my PC2. Clear, guys? And you can check the details that you have configured using the show commands. So show IP interface brief will now be written as show IPv6 interface brief. And that tells you the global unicast IP that you have configured, the link local address which was generated. Clear? Similarly, show IP route is the command. Now it will be show IPv6 route, which will tell you the routing table. So I can see the static route which we added. I can see my connected routes as well. This is how the IPv6 routing works. So go ahead, give it a try. I'm pasting the lab guide for this one. Try out the lab and let me know once you are done. Also, I'm sharing one lab guide in which you can understand how RIP can be configured for IP version 6. Now, in CCNA, you really don't need to have that level of understanding, or you need not to get into routing protocols. You just need to know the basics. But here it will make more sense if you will practice. So whenever you get time later on, you can test out these configurations for RIP and default routing as well, for which I'm sharing the lab guide. But yeah, as of now, you guys can try the one for static routing. And later on, whenever you get time, you can access the RIP one and the default routing one to practice the same. As I'll give you 10 more minutes to complete this lab. Please be quick, and then we will move to the next discussion. All right, I hope everyone must have completed this by now. Now it's time that we move towards the discussion related to automation. For understanding automation, there is a concept called software-defined networking that we will speak about, and we'll try to understand how it works. And then we will speak about some solutions of automation that can be used in the industry for different types of devices. I'm sharing my other screen again. I hope it must be visible now. Now we are going to have an introduction to automation and programmability. In order to understand automation and programmability, we need to know what is SDN. Can anyone tell me what is the full form of SDN? It is software defined networking. Now, some of you might have some idea on what is software defined networking, and some of you might be hearing or listening about this term for the very first time. Today, we are going to understand what is software defined networking, how it helps in managing the network in a smarter and easier manner. When we talk about networks, guys, networks consist of devices like router, right? Switches, firewalls, then we can say load balancers. There are some devices called intrusion detection system, IDS, intrusion prevention system, IPS. These are security devices. All these devices are manufactured by various vendors like Cisco, like Juniper, like Huawei, like F5, like Palo Alto, and the list keeps on going, right? The network engineers are expected to have knowledge of all these different operating systems, right? Because in a big network, in a complex network, you will find devices from multiple vendors. You will find some devices probably of Cisco, some devices of Juniper, some of uh, Palo Alto, and so on, right? So you need to have the understanding of configuring these devices as per the syntax that they follow, which makes it very difficult and complicated for anyone to work in an environment, right? So what do we do in such a case? The manufacturers decided to bring up GUI based devices. So they started bringing devices which could be managed using CLI. What is CLI? Command line interface that we use for configuring the devices and routers. We have been using it. And then there is GUI, which is graphical user interface. Yesterday, when we were working on a wireless router, it was configured using GUI, correct? So that makes it easy for a network engineer to manage the device, to configure the device. ASA is a device, a Cisco firewall, which stands for Adaptive Security Appliance. This is a device that can be managed using CLI as well as GUI for making it simpler and easy for network engineers to work in a multi-vendor environment. Not just ASA, there are multiple other devices also which can be managed and configured using GUI. There are multiple controllers. You might have heard of DNAC, vManager. all these are GUI based devices. You can manage them using a graphical user interface. Now, the second question is, why do we have to manage these devices? Why do we want to access these devices? So you want to access the device either to configure something new on the device, or maybe sometime to monitor what's going on the device, right? And how do you access it? We have discussed earlier that we can manage the router using a direct connectivity of console cable, correct? Or using a remote connectivity with the help of protocols like SSH or Telnet. By whatever way you access the router, you are going to configure something on that router, or otherwise you will monitor something, right? Let's think of an example. Let's say you have your router number 1 connected to a switch connected to multiple end devices. Then you have a router 2 connected to a switch and to multiple end devices. The network on the left side is 192.168.1.0/24. The network on the right side is 192.168.2.0/24. Between the routers, I am using 12.10.1.0/30. Now, in order to make this PC communicate to this PC, I need a routing protocol. Do you agree? We'll need some configuration of a routing protocol to implement or to exchange these routes between the devices, correct? So let's say we connected to these devices one by one and we configured EIGRP on it. Now, the moment I enable EIGRP, certain tasks will take place. We'll calculate feasible distance, we'll calculate reported distance, we'll figure out who is successor, who is feasible successor. Then we will find out, we'll create the routing table, we will create the topology table, the neighbor table, and the best route will be installed in the routing table, and the feasible successor, second best route, will be first checked that whether it meets the feasibility condition or not. If it does meet the condition, then it will be installed in the topology table. And then finally, the packets will travel over these interfaces to move from PC A to PCB, correct? And that is also not that easy. When my PC understands that my destination is in a different network, it will first give the packet to whom? To the gateway, correct? Then this router will check routing table, will try to find out some route which can take me to the destination. R1 will realize I have to give my packet to R2 for making it reach the destination. So I can say that R1 will use what protocol to learn the destination MAC address, guys? It's going to use ARP, correct? It's going to use ARP to learn the MAC address of R2. Then packet will be given to R2. R2 will again check routing table. It will find out what is the best route towards the destination. Then it will use ARP again for checking the MAC address of this PC. And then finally, the packet will be delivered to my destination. And the same process takes place when the packet returns back to my source PC, correct? So all these things that I have mentioned, starting from taking the access of the router, let's say through the console connection, through the SSH connection or telnet connection, then to configuring EIGRP, where dual algorithm gets into picture, and we calculate feasible distance, reported distance, we find out successor, we find out feasible successor. Then to using ARP for learning the destination MAC addresses, then to moving the packets from one interface to the other interface. All these tasks that we have observed and discussed so far are divided in three planes of router. What are these three planes? Let's understand. The three planes of network device include first, your management plane. Second, control plane. And third, the data plane. Management plane is responsible for giving access, like we said, the CLI access or GUI access. So the accessibility is provided to us using the management plane. After that, the calculations, the logical things like using feasibility condition, calculating feasible distance, calculating reported distance, finding out the destination R, or figuring out what is successor, what is feasible successor. All these things are done by control plane. So we can say control plane is the mind of my router. Finally, data plane is responsible for forwarding traffic. So taking the packet from one interface and putting it on the other interface is what data plane is responsible for. So let's understand the same using a graphical representation. Assume that this is my router. On this router, there will be a management plane. Like I said, let's say this is the management plane. Then there will be a control plane. Then there will be a data plane. The management plane of my router will be responsible for giving me CLI or GUI access. Now that can be through Telnet, that can be through SSH, or that can also be through the console cable. So when I interact with my device, I am going to use the management plane only. After I make any configuration, the change is made in what plane? Control plane. So let's say I configured EIGRP on my router. Then I configured OSPF on my router. And then I also configured some static routes. So the tables which are maintained by EIGRP are neighbor table, topology table, correct? OSPF maintains neighbor table and something called as database table. Static routing will not create any table. So all of the best routes from topology table and database table will go into another table called routing information base. And that will also be synced with the ARP cache, which is maintained about the destination MAC addresses. So best routes from topology table, from database table, and the static routes. All of that will go inside routing information base. Then as per the best routes, the forwarding decisions are shared with my final plane, which is data plane, which also maintains a table called forwarding information base, FIB, which is completely responsible for forwarding traffic as per the information provided by the control plane. So forwarding information base tells us where to forward the traffic. So we can say it is the data plane which will be connected to all the interfaces. So if there is 0/1, 0/2, It's connected to data plane only, right? As per the information of fib, it will receive the traffic or will forward the traffic depending on the source and destinations. This is how the three planes of network devices work together to process each and everything which goes inside a routing, which goes inside a router while forwarding traffic. Does that make sense to everyone? Okay. Now the question is, where is the problem, right? We have understood how these devices work. We have understood how these three different planes work together. The question is, where does the problem lies and what is the use of this software defined networking? So guys, the network has been like this only since the very beginning, and we have been using it for now 3 to 4 decades. And internet or network has been like this only. I'll give you one scenario and you will yourself understand where is the actual problem with traditional networks. Okay. So when we talk about a traditional setup, it is going to be simply devices. Devices which are connected together using the protocols that we have learned over this period of time, right? So assume that there is one ISP and this ISP helps me to connect to one headquarter branch. On my headquarter branch, there are two edge routers. Then there is a firewall. Then there is a layer 3 switch. Then there is a layer 2 switch. And then there is a server. Now, to make sure that there is redundancy, these are connected in a meshy fashion like this, so that if one device fails, the other one can take care of the routing. On this server, there are two virtual machines, virtual machine number 1 and 2, which are hosting some applications for my employees. Okay. So just understand that on my server, I am running two applications. Now, these two applications are accessed by employees who are there in a branch which is in Delhi and they're in a branch which is in Dubai. Okay, these are my two branches where my employees process and they access these applications which are hosted on my server. Now, to make this network work or to make these employees communicate with these two virtual machines, I need various configurations. I need BGP configs, right? I need VPN configs. I need some OSPF or EIGRP configs, correct? Then I need some VLAN configs. Probably some inter VLAN configuration can be there. There can be some SGP configs, there can be some HSRP configs, there can be some ACL configuration, there can be some NAT configuration, there can be some subnetting which can be implemented, and so on. Multiple other things, right? All these multiple protocols can be implemented here to make this whole thing communicate to each other. Correct? Which is also fine. That's not a problem. But the problem occurs when there is a change which is supposed to be implemented. For example, let's say now your business requires another application for which you have to host another virtual machine on your server. So to make the virtual machine number 3 reachable from Delhi and Dubai branch, I will have to add BGP configs. I will have to modify my VPN configs. I'll have to probably reconfigure OSPF. Maybe create some new VLAN, allow that VLAN inter-VLAN communication. Maybe reconfigure HSRP, right? Then adding some more rules into my ACL, maybe reconfiguring the whole NAT configuration, then subnetting might have to get redefined. All of that will have to be modified, correct? Do you all agree? And not just once, but for multiple number of times. First on this router, then on this router, then maybe some rule modification on firewalls, then some new configs on layer 3 switch, and like all the other devices as well. And like right now, we are looking at a simple demonstration, but usually the networks are actually quite more complex. So thousands of devices or hundreds of devices can be there. So configuring all of them one by one individually is a really, really tough job. And what can happen in that situation? You can make a mistake also, right? When you are, let's say, modifying your VPN configurations or when you are reconfiguring your ACL, you might end up making some error there, and your whole network will go down because of that error. Now you will have to again take some maintenance time to figure out where exactly the problem occurred and then fix that problem. Even if I talk about statistics, Cisco says that most of their tag tickets, what are tag tickets? Those who are not aware, Cisco can help you in fixing your network when you create a tag ticket with them. So Cisco says that most of the problems that companies or organization face with their network, they are fixed by fixing configurations. So most of the issues, most of the downtime is because of some misconfiguration that got implemented. So there are so many problems in a traditional network. Now these problems are addressed when we switch to software defined network. How do they address these problems in software defined networks? With the help of something called as controller. Now controller gets into picture. Controller will be used for connecting to my headquarter branch, my Delhi branch, and my Dubai branch. And what is the benefit of having this controller? This controller will have the access of control plane of all my connected devices, which means that I have taken the brain of my connected network devices and I can manage all of them directly from my controller by connecting a PC to it. So if I give some command to my controller will give it to the Delhi branch router, Dubai branch router, headquarter branch router. And because they have given their control planes to the controller itself, their ability to take decision by themselves is gone. They are now dumb devices who will act as per the commands provided by the controller. And what's the benefit of that? I can manage my whole fabric just by sitting at this PC. So I get a centralized access of control planes of my connected devices. And I can manage them all. I can configure them all right from my controller. Clear, guys? This is what software-defined networking is all about. Now, how automation gets into picture? Let's understand. So there are different types of devices. The routers that we have used were iOS router. Cisco offers different types of operating systems. iOS is the most basic operating system, and that's what we were using when we were using my 2811 router or a normal switch. These devices can be simply automated over SSH connectivity. Okay. Then there are some high-end operating systems like iOS XE, iOS XR, NXOS devices. These are used in data centers. These are used in organization as main router, the core router, which will take the data of your branch and will send it out on maybe using a VPN to some other branch, or will use internet or provide internet access to your complete branch. So these are the main devices, the high-end devices. these are automated or can be automated using some protocols like netconf and restconf. I'm just telling you the names. Obviously, these are not something we'll be able to discuss in CCNA right now. For that, we have a dedicated training, which is called CCNA DevNet. That's completely about automation, right? So there we learn how netconf work, restconf work. But as of now, we can understand these operating systems are managed using these protocols. Then controllers. All the controllers or GUI based devices are managed using REST APIs. APIs are used for configuring and managing the controllers, which are basically these devices. So these are the different types of automation that we implement in a given scenario or a network. I hope that makes a bit of clarity to you all about understanding how automation works in real life. And like I said, if you are interested towards automation or are keen to learn how Python works, how Python can be used for configuring interfaces, configuring OSPF, configuring EIGRP, and so on, all the activities. So there is a dedicated training for that, which we have called CCNA DevNet. Like in this normal CCNA 200-301 program, which we have conducted over the period of the previous few months, what we discussed was completely networking, right? So it was, I can say, 80% of networking. Then 20% or remaining, let's say 70 and 30 would be the appropriate distribution. 70% was understanding routing and switching, and 30% was divided in understanding wireless, understanding security, right? Understanding automation, and so on. So CCNA DevNet will be opposite of this. CCNA DevNet will be focusing completely on automation. So if you go for CCNA DevNet training, you are taught over 90% of the discussion would be over the automation concepts. You learn Python there, you learn different Python libraries that can be used for different purposes. So that's a good, I can say, course for anyone who is looking forward to learning automation or are willing to learn and explore Python for implementing network configurations. Other than that, uh, we are done with the content of our free CCNA training. We discussed a lot many things over the period of previous days. Like we started with the very basics and the fundamentals. We discussed the understanding of MAC addresses, IP addresses, spoke about the different types of devices. Over the period of time, we gradually got into routing, discussed different types of routing. We also talked about some protocols which are not there in the official CCNA content, but we did the discussion on them as well, just to make sure that you guys get a good understanding and you guys are market ready. Then we spoke about some switching concepts, some security concepts, some network services, and today we have got a little introduction to automation and programmability as well. I hope this journey was fruitful for you all and you got to learn out of it. I hope I was able to make a change in the level of knowledge that you had in the beginning and that you have now. So thank you so much for being constant and putting your efforts in learning this technology. I am wishing you all the very best for your future, for your studies, for your jobs, and whatever you do, right? Regarding the network engineer interviews and the knowledge or the vision that you should be having for your future now, you guys can keep your efforts, stick to learning more of networking. Right now, we have just started, right? We have just, got an entry to the world of networking. I'm so glad you guys are putting reactions. Thank you so much. And let's hold it for some time, and let's understand what I am saying. This is quite important part. So do realize what we are now looking forward to. So yeah, I was saying that now you have got an entry. You have just started. CCNA is the associate level. There is a lot more to explore. There is a lot more depth to explore. In CCNA, you get an introduction and you are provided with the fundamentals of topics. We touched OSPF, we touched EIGRP, we touched many protocols in great depth, but trust me, guys, there is much, much, much more to these protocols. There are so many additional features, so many interesting topologies, so many interesting features and examples with all these protocols that are still there for you to learn and explore. So it's a journey that you have just started. There is a lot more to learn. There is a lot more to understand and grab, right? This understanding or this knowledge can be built by upgrading yourself to CCNP or maybe CCIE in future, right? So a strong suggestion to all of you is that you still have to continue this learning journey, right? Because if you wish to grow, if you wish to learn more, then it's quite important that you keep learning and keep studying. So yeah, with that, I was talking a bit about the interviews. I'll be sharing some interview question answer PDF file. I'll be sharing the CCNA's official certification guide also, the official Cisco book that can be used for studying CCNA. And I'll also be pasting some uh, additional books that can be really helpful. Then with that, I think we are good for the training. Now you guys can paste your questions and I'll be more than happy to help you out. Also, regarding any of your career related question, a strong suggestion is to join the webinar that we are hosting, which I pasted about, I guess, yesterday also. So that webinar is there, which will be addressing all your uh, job related questions, your industry related questions. This is going to be hosted by Mr. Dipanshu Budija. He has been in industry for many, many years now. So someone you can definitely learn from. So do join that 17th May, 11 a.m. Indian Standard Time. That's the time when we are hosting this. So do join that. And other than that, certificates will be provided to you. Don't worry. My team will process the attendance. We'll see how regular you are. On the basis of that, you will be provided with the certificates. Thank you so much. It was really great training. Grateful for the guidance. Thank you so much, Dipti. Glad you found it interesting and got to learn out of it. Ankush has a question. What is the difference between NCORE and NRC? So guys, CCNP certification requires two exams, core exam and concentrated exam. NCORE works as the core exam. NRC works as the concentrated exam. If you want to become CCNP, so in routing switching especially, then these are the two exams you have to learn and crack. Core exam focuses on routing, switching, a bit of automation, wireless, whatever you have learned in CCNA, more depth to it is provided here in NCORE. Whereas NRC is advanced routing and services. So advanced routing and services. Here you learn how VPNs are constructed, how DM VPN works, how MPLS works, all those additional or advanced topics. That's the difference. And thank you enough for make the awareness of this program. Amazing. I'm so glad, Sayed, you found it informational. Thank you for good lectures. Thank you so much, KK. Yes, guys, the videos will be processed. We cannot define when it will be available. It will be available soon on our YouTube channel. PDF file. Sure, I'll share the PDF of the notes. Yes, this is the last day of our course. You are more than welcome, Shekhar. Thank you so much for the appreciation. Thank you so much, everyone. I'm so glad you guys learned out of this particular training. And a last request to all of you that if you haven't shared your feedback or review about this training, then I'll request you to do it today. As today we have wrapped up the training, I'm sure you must have got a good experience or must have got to learn out of this. So if you can just take out a few minutes to write about your journey and your experience with this training, it would be able to create the impact for the learners who are confused to maybe decide where to learn from, right? So if you enjoyed this, then I'll really appreciate if you can share about that experience on that particular review link. And with that, thank you so much. Give me some time. I'll post all these books that I mentioned and the interview questions. And all the very best again. Keep learning, do good. You can ask me questions anytime in this public group. Whenever you have a doubt, you can put your questions there. I'm always available. My team is always available, and they'll be try to answer your questions as soon as possible. Thank you. Bye bye. Take care. Have a nice day ahead.